Welcome to Business School of AI. We are at the LiveLab for machine learning with Julian Carbonell. And Julian is our instructor today, and he comes with rich experience when it comes to smart cities and data related to that. In Weekly Wed, we had invited Julian. Julian had explained about his scientific work and how he had used machine learning to come up with results. And today Julian is here to coach us about machine learning, which is a live lab using mobility data. And over to Julian, looking forward to your class.
Thank you, Yash, for the introduction. Yeah, I hope you will like it. So we will work today on making predictive models of on mobility analysis, and we will go through the whole process of mobility analysis from these data sets of the dockless vehicles recorded in Louisville, a city in Kentucky, USA. So let's start now. We'll go here. I will share my screen. Okay, I guess you can see it, right? And so, just like we did yesterday, I invite you to open the GitHub /democracy studio /livelab September 21. So you will have the whole content of the class of today. And then in a new tab, you will open your Google Colab. Here it is. When you go on your Google Colab, you have this window which pops up. It's a window to upload your data set, I mean your notebook. Here it is. It synchronizes with GitHub. I will copy paste the URL of the GitHub repository here. Enter. And then my collab will find the notebook that he has to upload. You just click on it. And here you are.
Can you just give the notebook URL? Oh, you did give that on the chat. Thank you so much.
Yes, the notebook URL is in the chat. Is the one of the it's the GitHub Democracy Studio. It has a dedicated file. So yeah, today we will process machine learning on mobility data. It has different steps. I will say basic steps. The first, it's always the same when you do machine learning process. Usually you have to first set up your environment and upload the data set. Then you clean a bit the data. You do first exploratory data analysis. These are basic statistics, I would say, on the data set. And then you will start to check for dependencies between the variables. You can make some data visualization to have a better understanding of the whole data set. And then we'll start to run a first machine learning algorithm on the variables that you want to predict. And finally, then you enter in a loop. So you will check the results of these predictions, and then you will try usually to make it better by testing different strategies. We will try different ones today. Basically, if you have time, so I will have much more things. There is a kind of surprise. I did so much more tries on the side, and I will be able to tell you and show you more if you have time today. But let's start with these ones. So as you can see here, you have a list of boxes. Each of these boxes is commented with a dash and a green sentence. So it tells you what's inside the code that you will be running. So each time you click on the play button at the left of your box, you will run the code that's inside. So the first one is to set up the coding environment. Here you can see that we are importing the different Python libraries that we will need to use for this data analysis. Run anyway, okay. Okay, here we are. Then, since we are working online, it's tasked to connect the drive with the Google Colab. So my data set is now hosted on yes. And then okay, it gives me a key that I'm copying to access my drive from the Google Colab.
Julian, just a request from my side. Can you please zoom a little more so that we will be able to see it? This is good enough, but to get more clarity, I just thought little more zooming will be required.
Okay, something like that.
Thank you.
Okay, cool. So yes, now the drive and the Colab are mounted, and so I will upload my data set, which is located in the drive. I call it dockless. So you will see all along the data analysis, when I say dockless, it will call the data contained in the CSV file. And so let's check how what's the size of these data sets. You can see that there is 505,000 rows and 13 columns. That's way too much to open it with the usual Excel or Google Sheets or numbers on Apple. So when you start working with big data sets, you definitely need to run it through this way. And then we can take a look at what's inside with a preview using the command head. And it gives you the column name, trip ID, start date, start time, and you have the 5 first rows, which gives you an overview of the content of the data set. So here we have trip duration, trip distance, start latitude, start longitude, okay, this kind of information. First thing first, we want to clean the data set. So as you can see, these headers of column are not really convenient because they use an uppercase for the beginning of each word, like trip duration. So it has a big T and a big D. And honestly, yeah, from experience, it's always boring when you have these kind of things because it always goes into some typing errors. So for example, here you are trying to call the column to check if there are new information inside, and you do it with only a big T and slow D. And what happens? It rises in error, of course, because there is a typing error. So to avoid these kind of things, usually we rename the column headers with lower cases only. Here it is. And then you can see that you have all the headers with lowercase, so no more mistakes in typing these things. So then we run again the trip duration sum of null, and we see that there are no null values inside the trip duration column. It's a bit weird because when we check here, we can see that, yeah, trip distance, for example, has some nulls. I think it was the same on some, yeah, trip duration. No, here, sorry. So yeah, trip distance, this one that I wanted to check. So there are no null trip distance, but there are some zero distance. And to be honest, we don't want to use this kind of distance where it is zero because it has a lot of probability for being a kind of bug in the application. Maybe someone started the trip using the app, and then I don't know, he he didn't cancel the trip. So basically the vehicle is not moving in this case when it has a trip distance of 0. And so we don't want to mess our statistics with this kind of information. So what we will do now is that we will delete all the cases. You see that there is 85,000 of situations, data points where the trip distance equals 0. And so now we just want to delete it from our data set. Here we go. And now we have 420,000 data points, which is better. Then let's check what's inside the day of week. So here we go. Like the day of weeks are recorded by numbers like 4, 6, 7, and we don't even know how they start counting, because in some calendars, Sunday is considered as the first day of the week. In some other calendars, it's Monday. So yeah, we don't exactly know how they do it. So we are importing a library called datetime, and we will print the date. So I chose the date, which is matching with a day 1. Let me go here. Yeah, you see here, it's day of the week 1. So I took the date that matches with the day of the week 1. And I check with the calendar which day that, and they tell me the first day is Sunday. So basically from now I am creating a dictionary of value. When I'm telling, okay, days, that's the name of the dictionary, the value 1 equals Sunday, value 2 equals Monday, value 3, Tuesday, etc. Yes. And then I make a replace of the value in my data set. So I'm telling into the day of the week column, each day of the week will be replaced by the values contained in the dictionary days. Okay, here it is. And now I do a check of the data set again. And here we go. We are having our days properly written in the column day of the week. It's much more clear to read it. We will do the same with the hour num. So we are checking the number of unique hours in the column hour num. And we can see that they have 25 hours listed. This is a bit weird, right? And so when you take a look at what's inside the hour num values, you can see that they have 24 and 0. So it's basically the same hour. So just like we did for the days, we are creating a dictionary that is called midnight. And in midnight, you are assigning 24 as the 0 value. And I even do it for the other columns, start dates and end time. The start time, sorry, and end time are 2 columns, which are also manipulating hours. So I'm creating this dictionary, and I'm replacing the values to have midnight set at 0. Now we can check again. And here we go. You can see that you have 24 values going from 0 to 23. So that's the basic steps of data cleaning. Let's go on some exploratory data analysis. Usually exploratory data analysis, they are basic statistics. It consists of looking at some distribution of values, calculating means or standard deviations, and then you will plot histograms or distributions depending on the day of the week. For example, this is something that we will try. We will be interested in checking which day is the most crowded in terms of vehicles traffic. And we will do the same with the hour. So let's start by checking some information here. The mean of the trip duration. Okay. It's said that the mean of trip duration is about 15 minutes. And then we will check the standard deviation to have a better overview of this value. And wow, it's pretty scattered, right? 21 standard deviation on the trip duration, it means like the values are going from 15 minus 21, which do not make any sense, right? So let's try to take a better look at it. You can call another Python function which is called describe on the column trip duration, and here we go. So you have more information. You find the number of values in the trip duration column. You find your mean, your standard depth, and then you have some useful information. So we can see that the minimum value in the trip duration is 0. Okay, no worries. 25% for the first quarter of your trip duration values is 5. Okay. The second quarter, it's like the median value. So 50% of the data set is separated in less than 9 minutes and more than 9 minutes. This is a bit weird because our mean was at 15, and having such a gap between the mean and the median value, it's always a bit like weird, you know. So we check at the third quarter, not seems to have big problem, but then we check at the maximum, and you can see that the max value is more than 3,000 minutes. This do not make sense, right? If we want to check how much it means, so it means like 52 hours, a trip of 52 hours with an e-scooter or a bike. Honestly, like it's very probably someone who forgot that open or didn't close his trip or whatever. So this is very probably an outlier, which is affecting our statistics. So we don't want this value. It do not make sense for our EDA. We will start to plot it to have a better understanding of the distribution of values. And as you can see here, we have trip duration and the number of records. There is a very big peak that is probably like going between less than 200 minutes, and there is absolutely nothing after that. So we can start to frame our data sets in tighter windows. We'll start to do it with 4 hours time here. Okay, we plot again. It's better, but still we can see that most of the trips are happening into 19 minutes, right? So we will tighten the window again. And here we go, we have something much more interesting. Okay, so we can check that most of the trips are happening into 20 minutes, and there is a peak that is about 5-minute trip, to be honest. Yeah. So they are not so long trips. Then we want to check with the day of the week. So how many trips per day has been recorded in this time? And we can see that Saturday is the most crowded day. Then you have Friday, Thursday, Sunday. Okay, so basically, this is ranking the use of our service. You can even plot it to have a better like visibility on the difference between Monday, which is the less crowded day, and Saturday, which is the most crowded. We will do the same with the hours. So it is not ranking the hours in the usual hours of the day, 0, 1 to 3. It goes with the most crowded hour. So the most crowded hour of our service use is between 3 p.m. and 4 p.m. So it's not bad to know that when is the service the most crowded. We wanted the sorted. Here we go. And so this is, I mean, this is a drawing of the peak of use during the day. Yeah, so we can see it starts being crowded by the end of the morning, and it starts being better by the end of the afternoon, basically. It makes sense, right? This is where the city is the most vibrant. Is every day the same? So this is the whole day's information. We want to check if it's the same for each days. Do people behave differently in the use of the service depending on the day of the week? Okay. So here we go. Apparently, it's kind of the same distribution always, right? There is a real peak on Saturday about 3-4 p.m. But otherwise, yeah, all days are distributed in the same fashion. So great, that was informative. We know more about the use of our service, but now we will start to check for dependencies between variables. We want, for example, to know if there are some relationship between, I don't know, the trip distance and the day of the week. Or I mean, do people travel longer on the weekend? This is something that maybe we can ask, you know, as a service provider. You can imagine that people are more busy during the working days, and they are more chill during the week, the weekend, so they will use the service differently. So these are these kind of questions that can pop up in your mind when you want to try the relationship between variables. And for that, we are using correlation matrix with a Pearson coefficient. So Pearson is a coefficient that is used to check the intensity and the direction of the relationship between two variables. So we usually call it like that, and we have a matrix of values. So negative values say that there is a negative relationship, which means that when one is going up, the other one is going down. And positive values means positive relationship. But still, it's a bit hard to read like that with bare eyes. So we usually deploy some heat map, which makes convenient colors on that values. And now it's much more easy to read, right? So you can see like the dark color are hardly negatively correlated values, and the lighter color are the ones that are positive, highly positively correlated. So here on this graph, usually when you check the correlation between variables, you consider that above 0.5 or under minus 0.5, there is correlation. Otherwise, all the intermediary values are not considered as correlated enough to say something, right? So here we have two correlated values. We have the trip duration and the trip distance, which are positively correlated together. And there is another hub here, which says that the end latitude and the end longitude are negatively correlated. Honestly, this one means no sense because the end point is the same. So it's just, this is not a meaningful information. But this one is really interesting, especially for the coming machine learning model. So,
Julian, can we zoom in a little bit more?
Yes.
It looks like Suresh had some comment. Anybody can write your questions on the chat, please.
The question I had for Julian was, I thought the trip duration 0 was removed from the data set, but in your distribution, I see the minimum value of 0. So I'm not sure I understand that. So is now, right?
Yeah, that's a good question, but honestly, we are working with a lot of content of data, so maybe we can dig in more detail for that. The reason why I deleted 85,000 data points that were equals 0.00, it's that it's affecting the mean because it says nothing, but probably the system is keeping data points that are 0.01 or 0.02, so very short distance, and so it kept these ones. And yeah, and then when it plots the values, he probably like makes he's rounding the data. So we still have some zero information, but the 0.00 has been deleted.
Okay.
That's my explanation like that. Yeah.
All right. Thank you, Julian.
Thank
Cool.
you.
So now let's check some data visualization. Here, I would like to visualize those two data which appear, those two variables which appear to be correlated. So I'm using a scatter plot to have an overview, okay, of the trip distance and the trip duration. It's very crowded, right? It's also scattered a bit in some values that are yeah, not close to the mean at all. So to have a better view on what's actually in my data sets, I will plot a subset inside a tight window. So here I will select the trip distance that is under 20 miles and the trip duration that is under 500 minutes. So basically we are plotting the first square here. Okay. So it's more readable. We see that there is a lot of data points basically, so it makes it hard to check if there is really a correlation between these values, relationship between these variables. So
Julian, I think that shows what you explained. That graph on the left side, it shows you the trip duration of not exactly 0, but 0. Some numbers, right? So
yeah,
can be 0.0001 or something like that. Perfect.
And so now we are making a joint plot. So you will see there is more information on the same data window. It will tell you more. It will be more visual. You will have notably one linear regression line and some histogram on the side. It takes a bit more time. When you run it in local, it goes faster. But when you run it online with Google Colab, sometimes it takes a bit of time. It's processing a lot of value, so it's coming. The next one, notably, is very maybe jump the next one. It can take too many time. Oh. Okay, it's coming slowly. Yeah, well, I will use that time to check the chat. I don't know if there are some other questions. So here you can see the relationship between the trip distance and the trip duration. So we can see that there is actually a relationship that makes sense, and yeah, I mean it confirms the correlation matrix and make it more visual. So this is a visualization of the spatial distribution of the data points. I'm doing it on the whole data set, and to be honest, it will take a lot of time. I tried it even in local. It's kind of long because it's plotting all the position of the whole data points. So if you don't mind, trust me, this will take a lot of time. And maybe we can just jump this one. And what I'm doing then is that there is nothing very visual, because we have like a lot of points that are located in the center city, and then you have a few points that are very scattered in the space. So what I'm doing at that time is that I'm generating a random sample of 1000 data points here, and then I'm plotting again the spatial distribution of this sample. It goes faster, of course, because it's only 1000 data points. And so now we can see that, I mean, this is not on a map, but still it's a spatial distribution of the latitude and the longitude of 1000 points selected randomly. And you can see that it's already like, we can imagine that this is probably the center city with the most crowded streets in the city, right? So we want to have more understanding on the spatial distribution of our trips. And so for that, we will use some plugins that help us to display maps. It's called Folium. So we import these libraries. We will enter the coordinates of the Louisville city. I picked that on the web. So Louisville is defined with that latitude and longitude, and then we can generate a map of Louisville. Okay, here we go. This is the map of the city, and on that map, we will add some points. Sorry, I will make it big again. Okay. So what we are doing now is that on the map of the city, we are displaying the latitude and longitude of the start of the trip. So it's the origin points, and we add that on the map. And as you can see, we are finding the same kind of spatial distribution that this one, right? It's exactly the same. It just puts on the map with the actual records. So, well, you can zoom on this one. And if you want to make it more readable, you can also cluster the points. This is probably something you already saw on some websites or web maps, right? So, and then it gives you like the perimeter and the numbers of data points inside the perimeter. And then imagine we want to check which is the most crowded places in the city. So for that, we are using a heat map. And here we go. We have now the most crowded, like the most burning actually points in the city. So when it's blue, it's kind of cold, and when it's orange, it becomes red. It's where it's the most hot place. So we will do the same with the destination points, not all of it, but we will just like from our sample of 1000 origin points, we have now the destination points that are corresponding. And then we will try to make a link on the same map between the origin and the destination points. Here we go. These are straight lines. So we do not really like consider the shape of the trip inside the streets, but still it makes you it gives you an overview of where the trips are starting and ending on the map. And it also gives you an idea of the distance and of each trip. And what we will try to do now in the machine learning is that we will try to predict the duration of our trips based on the distance. So here is a recall of the problem statement. What data do we have at our disposal? We have origin and destination points. We have a trip duration. We have trip distance, the day of the week, and the hour of the day. We have seen that the two only data that are really correlated are the duration and the distance. It makes sense if you think about it. And so now we start to check our machine learning algorithm. So we check for the data types. Basically, these are the data types of each variable. We can see that duration, distance, the one we are really interested in, they are float numbers. Same for the latitude and longitude. But then we have some objects. We actually need that objects variables. Not really. So I will define my X and Y axis. It means like the dependent variable, which is the trip duration, the one we want to predict, and the other ones by excluding the object that type. And so we'll only integrate the float values inside the X axis. Here we go. What we usually do is machine learning is that you split your data set in two. You split your data set in a test subset and a train subset. And so you first train your algorithm on the train subset, and then you test its performance on the test subset. Yeah? And usually we do 1/3 for train and 2/3 for test, and it's all selected randomly. So it's absolutely like 100% selected randomly. So we don't mess with the computer, and we cannot fake the results. So here we will start to use this linear regression algorithm. So we call it with sklearn. We import a model called linear model. And so as you can see, we will fit the model on the train subset, and then we will ask him to make predictions on the test subset. And so basically what the machine learning algorithm will do at that point is that he will predict the Y tests, which means he will predict the trip duration based on the other variables. Here we go. There are not that many, it's not really visual, there is nothing to visualize from a dataset prediction. They are just a series of numbers. So what we usually do is that we calculate statistical measures to have the performance of your model. So now I can see that I have a mean absolute error of 7.8. It means like the model is making 7.8% of errors in his predictions. I will not detail the other values, but it's kind of the same way of expressing the performance. We can visualize the model performance by making a plot of the predicted values and the actual ones. Here we go. This is not really, it's not really visual. We should be like tighter. We can plot the residuals. And yeah, same, the window should be like more still, I mean, these are ways to visualize the machine learning performance. So, well, 7.8, honestly, it's not bad, but we will try to make it better. So, as I told you, machine learning is looping through data sets and trying to find the best combination of data to have the best performance in predictive tasks. So what we will do here this one will be to, yeah, this is a feature importance plots. So we will try to plot the feature importance in the predictive task. We are training the algorithm on another classificator. So this might be a bit confusing. It's maybe a bit more advanced, but what you can see here is that from the 6 variables that has been selected in my X axis here, right? We dropped the Y, but we kept like the 6 float number. We can see that the one feature that's having the most important is not named here. It's called 0, so it's the first one. This is the one that we've seen here on the correlation matrix. Yeah, it confirms that the trip duration is the one, the trip distance, sorry, is the one that's having the most importance to plot to predict the trip duration. So now what we can try to do is that we will reduce the feature of our data sets to achieve a better performance in prediction. We are indicating here that we want to select only one feature. So we are fitting the model now with one feature. It tells you that we selected one feature, the first one, and yeah, it was the most important in the ranking. So again, we will do an XY train test split. Here we go. We will make a linear regression again, and we will check the performance. As we can see, it is not really better. We were at 7.8. We are now at 7.93. So basically, it tells us that these not so important features are actually playing a teeny role in achieving predictive performance. So yeah, this was not the best strategy to improve it. We will try another one. You remember that we selected a shorter data set. I assume that if we delete the outliers of our data set and we select a more tight window across the mean, we will have some better predictions. So here what I'm doing is that I'm creating a sub data set. Okay, I'm doing my train test split again. I'm doing some more predictions here. And this time the performance is better. We are at 674. The last try, I want to improve it again by selecting only the trip distance that are under 20 miles, sorry. Okay. Again, always the same task. We are splitting our train test. We are doing a linear regression. Okay, and we check for the performance. And now we achieved a performance that is at 5.98. So basically, we went from 7.80% of errors to 5.98. So it's better. And so yeah, in conclusion, you see that I've been looping like 3 times, I think, on the same algorithm with different combination of data sets in the loop for the best prediction. This is exactly what intelligent machines are doing. So yeah, you are testing different combination of data and try to reach the best performance. Usually when your accuracy score goes to more than 95, it means like it makes less than 5% of errors, your model is considered good for production. So you can run it on whatever data set and you assume the predictive task will be acceptable. So it has a bit more work if you want to sell, for example, a data app based on this machine learning algorithm. But still we are not so far, right? So we can be proud of achieving this performance. And in a more advanced version, I could, for example, have done other kind of predictions, for example, on time or on spatial data. For example, we could have tried to predict the car traffic based on the day of the week or the hour of the day. We could have tried to predict the destination of a trip depending its origin point and duration. So these are kind of more advanced predictions that we can do with the same data sets. And if we have time today, we will see more. But now it will be your turn. So basically, there are two options. You can start, we will assist you. So we will now go into the workshop where first I will ask you if you have some more questions and check the chats. But then we will let you work and perform this data analysis on mobility data sets by yourself. You can run the same data set or you can run the other one, which is similar, but it's smaller. So maybe it will be more easy for you to manipulate on the first case study. So do you have any kind of questions so far?
Julian, in this prediction, you were predicting the trip duration to the trip distance. Is that correct? Or what was, did I miss something?
Yes, exactly. Yeah.
Okay. And also, you know, the other kinds of analysis, maybe can you add that to this page, to this file so that, you know, people who would like to do that, they can go ahead and extend this analysis further.
Yeah, this is the usual behavior when you are doing that analysis, especially on I mean, especially on open data. That usually, since you found things in an open way, you are sharing your work, so it keeps being open for the other people.
Right.
This is something that I'm usually doing. This is why my GitHub is all open. But still, I mean, for example, I have recorded some more information on these data sets. I do not have the power to share it on the Louisville Open Data Repository. I mean, the city is providing raw data sets for the people to be able to play with that. It's part of the policy transparency. But yeah, I mean, it's not my role to provide some more data for a city. I don't know. So yeah, all this is available on my GitHub, and yeah, this is how we usually do.
Thank you.
Okay.
Thank you for this wonderful class, and we learned how we can use mobility data for a machine learning use case. Generally, when we look at machine learning and we say that it's a part of artificial intelligence, and the general problems that we see in machine learning comes to classification and regression. We generally have this problem of churn prediction, whether a customer will churn or not, and we have a price prediction. But to see that you have done related to mobility data is something of one of a kind. The first time I've come across this. And I think it'll be a very good add to my resume.
Cool.
Thank you.
Thank you.
Hi, this is Alex. Thanks, Julian, for everything today, and the
You're
rest of you.